Hello, friends. Good morning, good afternoon, and good evening. Wherever you are in the world, make a great day. As I committed, I am bringing you a new topic, and that topic is a UDS. So let's learn about the UDS. What is UDS? So in this knowledge sharing session, I'm gonna cover on the different areas. Like we'll start with the introduction. Then we will see what are the different UDS services available and how the message structure looks like. When you send the UDS request, what is the frame, how it looks, and in the response, what you get, and how to decode that frame. That I also will cover. So I'll also touch to the negative response codes. And then, as I said, there are different UDS services available. Out of that, I will cover in detail about the diagnostic session control service, then security access service, right, by identifier service, and then we'll jump for the live example. So in the live example, I'll just cover you in the detail about the diagnostic session control service, but hopefully that will definitely make you aware how you send the request and how you get the response that you can see in the live example. So let's start with this UDS, with this knowledge sharing session. But before jumping to the introduction part, it is always necessary to understand why the protocol is invented and what is the need behind that. So this is I'm gonna cover in this slide. So what is the need? So as you know that with the rapid evolution of electronics in the vehicle, the need to track and control vehicles' different parameters in drivability point of view was very crucial in the past. Thus, diagnostic systems were developed up so that the clients could detect the fault in the vehicle by connecting their diagnostic tester tool to the ECU. But there were so many manufacturers in the world, like Mercedes, Tata, Mahindra, Audi, BMW, Volkswagen, JLR, Toyota, Scania, Volvo, etc. There are so many um, players in the market and which had its own software architecture and software in its easiest way to handle it. So it was not possible to make one tester communication language for all car brands. That was the challenge in the past. So in order to make sure that all these cars could communicate with a single generic testing tool, SAE, that's the Society of Automotive Engineers, came up with a standard protocol for tester communication. And this protocol is named as a Unified Diagnostic Service, that is a UDS protocol. Every ECU in every vehicle must be able to communicate with the tester tool. That's for the UDS protocol. So tester can trigger various actions in the ECU, and that I will cover in detail a little bit later. So here I just talked on the history, what happened, what was happening earlier, and these points earlier. First 3 points covers the need and how it is this essay took place into development of this UDS. So basically, what is UDS? UDS is a client server topology. So let's understand what is this client server topology. So there is an external hardware tool which connects to the vehicle either by KWP 2000, CAN or lean protocol. That is very important. Just imagine there is one hardware tool which you are connected to the vehicle with some interface, and what that protocols are: KWP protocol 2000, that's a CAN protocol and lean protocol. With the help of these tools, you are communicating with that hardware interface to the vehicle ECU. Okay, so this tool is called the tester. Whatever the hardware interface you are connected to the vehicle, that tool is called a tester, and it sends the different commands basically. So what command it sends, why it sends the different command, and in that command, in that response, what you get from the ECU, that definitely will understand shortly. So the tester triggers various actions in the ECU, and that actions are like clear memory, flashing program, writing data, requesting data, and so on. So ECU receives the command that inform of the request and provide the service accordingly. So ECU is preferred as a server here. important is that this external hardware tool is called as a client and the ECU as referred as a server. This is very important to understand what is the client server topology. Client sends the request to the server and server responds to that request, whatever the request he received from the client. Now, very simple, there is one hardware interface, right? And we are calling that is a tester. It is requesting some service, and for whom it is requesting service in the vehicle, that's the ECU. So tester is hardware interface and ECU is there. So ECU, now just imagine this tester is being called as a client. Why? Since tester requests a service, it is called a client. And since the ECU receives that request, service request and provide the service, so called a server. So ECU called as a server. That was the client server topology. Very simple language. This is a tester and this is a ECU. But as it is requesting the server services, that's what this is called a client and this is called a server. So what are the services this client request to the server? Clear memory, flashing program, writing data, requesting data, and so on. So many services are requested and so many services are responded by the server and everything is implemented in the ECU and that everything is defined in this UDS service. And accordingly, the server responds back. Okay. So now let's jump into the introduction part. So what is UDS? So UDS, it is a communication protocol used in automotive electronic control unit called ECUs to enable the diagnostic, firmware updates, routine testing, and many more services. And we'll see shortly what are the different services. So ISO 14229 standard defines the UDS in 5 documents, and part 1 covers the UDS services. That is very important. If you have this standard, you can go jump for the part 1, which covers all the UDS services available. Okay, so important part is that this UDS protocol, ISO 14229, is standardized across both manufacturers and standards such as a CAN, KWP 2000, Ethernet, Lean. So UDS is used across all automotive industries like OEM, Tier 1, Tier 2 supplier. As I explained earlier, in practical, UDS communication is performed in a client-server relationship, with the client being a tester tool and server being a vehicle ECU. Very important that targeted ECU must support the UDS services. It will respond accordingly, and this serves various use cases. Read or clear diagnostic trouble codes, extract parameter values such as temperatures, state of charge of the battery, vehicle identification number, any active faults, modification firmware, reset issue, so many services. So UDS is a collection of various diagnostic services, which I just explained you. And each service has a service identifier assigned to you, and it's a unique service identifier. That is very important to understand. And that identifier is called a service identifier. So UDS defines what are available services, format of the request message, then the format of response message, what must be timing parameters, and the service handling mechanism as well. Everything is defined under this UDS. These are the common terminologies which you need to remember. That's service identifier, request, response, timing parameters, and service handling mechanisms. That way the UDS defines everything. Let's see what are the different UDS available services are there. So the first, there are lot many services available, around 30, approximately 27 or 30 services are available defined in the UDS standard, like diagnostic session control, ECU reset, security access, communication protocol, authentication, control DTC setting, respond on event, read data byte identifier, blah, 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 read scale data byte identifier, write data byte identifier, clear diagnostic information, and so many services. All these services are available under the UDS. As soon as you send this code from this client to the server acts accordingly, responds accordingly. That means when the tester sends specific request, specific service according the ECU response. But before jumping in detail, let's understand how the UDS message structure looks and how it works. If you understand that message structure, you will easily understand the protocol. So as I said that UDS is a request-based protocol, right? The request is coming from the tester and the ECU response. So a diagnostic UDS request on CAN contains the various fields. And we are talking about the UDS over CAN. Okay, so let's see what are the different fields. So first field is a CAN identifier. It's very common. As I explained in my first knowledge sharing session, that's the CAN fundamental. It's very important when you are sending the CAN frame into the network, each frame should have the CAN identifier. So that's what we are starting with, the CAN identifier. Then the protocol control information. That is another field that is very important. Then the service identifier. Each service has a unique identifier number assigned to it, and that number is called a service identifier. Then the sub-function byte. If a specific service has a scope to have the multiple sub-services, then that is called a sub-function type. Okay, and then the next field is a request data parameter, and the last field is a padding field. So let's see more in the detail how it looks. So the first is a CAN identifier, followed by the protocol control information PCI field, followed by the service identifier, followed by the subfunction byte, then the request data parameter. That is the DID actually, where you request different parameters with the help of the data identifiers. And the last field is a padding field. This is how it looks. Now we are gonna look each field in detail. What is the use of this field? What is the use of this field? What is the use of this field? We will understand. Once you understand, then you will understand how the UDS message looks like and what is the structure. Okay, so let's see. Let's start with the protocol control information. So PCI field is not per se related to the UDS request itself, but it is required for the diagnostic unit request made on the CAN bus. This field is a 1 to 3 byte long, so it's a variable field basically. Sometimes it is a 3 byte, sometimes it is a 1 byte. And it contains the information related to the transmission of the message that do not fit in the single CAN frame, right? So when the information is not fitting in the single frame, that information is sent with the help of transmission communication protocol, that TCP/IP. We call it as a TP, that transport communication protocol, right? So ISO-TP is an international standard for sending data packets over CAN bus. The protocol allows for the transport of messages that exceeds the 8 byte maximum payload of the CAN frame. And you know that in the CAN, you cannot send the data more than the 8 byte. And if the data or the payload is more than the 8 byte, then you need to use this TPCM and TPDT fundamentals. TPCM is a transport protocol connection management. TPDT is a transport protocol data transfer. Okay, so next field is a service identifier field. And uh, this is a mandatory field for all the request messages in the UDS. Just imagine this SID, this service identifier is a 1 byte in length, and uh, not imagination, it's actually it's a 1 byte in length, and its range starts from 00 to the 3E. I'm talking in the hex. So each service has a service identifier assigned to it. Server understand which service is requested by the client, and this is a mandatory field for all request messages in the UDS. So sometimes it is referred as a UDS service ID. When you wish to utilize a specific UDS service, request message should contain the UDS service identifier in the data payload. That is very important. So ability to the response seeds generally adds the 40 to the requested seed. But when the positive response is there, if you're sending some request and that service or that according to that request is implemented in the ECU, then the ECU generally adds 40 into that seed, and you get the positive response. If it is not the positive response or the service is not implemented, then you get the negative response. And you will understand what I am saying here, what is the 40 added, you will easily understand in coming time. Okay, so we'll see it shortly. So let's see more about this service identifier. So these are the few services. Okay, if you see here, this 10 is a diagnostic session control. If you have the positive response, in the response code, in the seed field, you can get the 50. Taking the another, that's the ECU reset. If you want to reset the ECU with the help of the request sending from the tester to the ECU, and if ECU get reset, if that service is implemented into the ECU will respond saying that yes, this service is implemented, and accordingly the ECU will get reset and you'll get the positive response. So for every service, whatever the service I have articulated here, listed here, for all service, if you see the positive response, 40 is just added. So whenever you came across or will come across any of the UDS message where you see you are sending some request, and in the response, if you see you getting added 40 in that service, that means you have positive response. EC is responding positively, that service is implemented. Very simple. And for the negative response, it is very common, very single code that the 7F you get. So let's say I'm expecting let's say uh, secure data transmission, but this service is, let's say, not implemented into the ECU. And if I send this request to the ECU and if not implemented, then the ECU will respond in the seed field in the response frame message with the ID of 7F. So you will realize that if you get the 7F, that means it's a negative response. Okay, so let's see the subfunction byte. The next field is a subfunction byte. Now, the subfunction byte is used in some UDS request frame. So this is not a mandatory because for every service, you cannot have the subfunctions. For few of the services, there is a subfunction. That's what it is not a mandatory, it's an optional field. And that's what this function byte is used in some of the UDS request frames. This tells servers for service which subfunctionality is requested. That is important. So this is optional field, and this is also has a 1 byte in length. So in some UDS services like 22, this subfunction byte is not used. And when request is sent to the ECU may respond positively or negatively. This is based on the implementation at the ECU side. We'll continue on the sub-byte function. So let's talk on the UDS service or the subfunction types. Okay, so in case if the response is positive, the tester may want to suppress the response. And this is done by setting the first bit to 1. Okay, so you see there are few of the UDS requests, and these are the positive response. Okay, now example, there is a service, and this service is a diagnostic session control, right? And here you got the positive response. Under this diagnostic session control, you could have the different subfunction. What are the different subfunction? That means you are entering into the diagnostic session. Yes, you want to enter into the diagnostic session, but what are the different types of the diagnostic session? First one is a default session. Then the programming session. If you want to program the application code, if you want to program the boot um, software, then you need to specify with the help of this subfunction byte. If you want to enter into the extended diagnostic session where you can have the right to write byte data identifier or access the memory variables or set the keys or read the keys, that services are available in the extended diagnostic session. So imagine that there is a one service that depends about the diagnostic session control, but inside this you have sub functions, right? And what are that sub functions? These are the sub functions. So that way, for all services, sub function byte is not applicable, but for the few of the services, definitely there is a sub function. If I say the 0 for that means the safety system diagnostic session. And so this is how the definition for the sub function which falls under the diagnostic session control. So when request is sent to the ECU and the ECU may respond positively or negative, as I covered here. So positive response, the tester suppress the response done by setting the first bit to 1 in the subbyte function. Okay, the negative response. So negative response cannot be suppressed. Um, so remaining 7 bits can be used to define up to 128 subfunction values. For example, reading the DTC information via service identifier 1919, the subfunction can be used to control the report type. So here you can see the positive response and some of the report types, how you got the report in the form of the response. The next field is a request data identifier, request data parameter. Sometimes this field is called data identifier field. So that's what did. And this includes the data identifier with a length of 2 byte. So in UDS, client server communicate only by the number, not by the string. Now carefully listen what I gonna tell you here. That is very important. In UDS, when the tester and the ECU communicate to each other, the client and server communicate to each other, they only communicate by the number, not by the string or not by any other way of communication. Okay, so if you want to read the information, any of the information, the data element from the ECU like motor speed, battery voltage, battery current, battery state of charge, with the help of the tester, with the help of the services, then you cannot put the string motor speed or battery voltage in requests. That's not possible in the UDS. So all the data elements which tester may read, they must be assigned with the predefined number, and this number is an identifier for that particular data element in the UDS, and this number is of 2 byte length, and this number is called as the data identifier. So just imagine if you want to read the motor speed, there is a specific number assigned to it, and that is a data identifier. If you want to read the battery voltage, there is a specific number assigned to it for this reading this parameter or this signal. If you want to read the vehicle identification number, if you want to read the vehicle speed, mileage accumulated, or any information from the vehicle, there is a predefined identifier that specific service, and that is called that is the data identifier. So in most UDS request service, various types of request data parameters are used, right? And this is to provide further configuration of the request beyond the seed and optional subfunction byte. Okay, so these are the standard dates which are used, but out of that, it is up to the manufacturer. If they want to add more dates based on their need in the vehicle, they can implement, and the same logic, same software needs to be implemented into the diagnostic tester tool. But there are some standardized data identifiers, and these are the standardized data identifiers. If you see F180, that's the boot software identification. Excuse me. Then F180, it's the issue serial number. F191, ODX5. So these are the standards. And out of that, as I mentioned, based on the specific need, you can implement the data identifier in both way, in the ECU as well as in the tester, and accordingly we'll get the response. So likewise, different data elements. The next very important, that is the padding field. Sometimes it is referred as a data record field. So this field is a record field, and this field is optional as per the service request. And example for this service is a 22 read data byte identifier. And this service does not need any data record field. It is not required actually. Why you need? You are reading the data from the ECU. You are not writing any data to the ECU. So padding or data record field is not required in this service. So again, that's what this is optional. So after mentioning the data identifier, you need to tell the ECU what the data value has to be returned to that data element, right? So example service 2E, that is write data by identifier and need a data um, to record field in the request. So data identifier tells that data element is referred, and the data record or fading field specifies what new value has to be stored in that data element. So this is again important. So example, suppose did just an example 8490 expect the minimum current limits from the battery side. So you are setting up the minimum current limits with the help of tester into the battery issue in the BMS, then definitely the tester should tell what is the new limit, right? So it should write that value as well. It is not just reading the value, it is modifying the current value into the ECU. That means it is feeding the data in terms of the record field. It is feeding that data into the frame to telling the ECU that I need a new value, I need to modify that limits, right? So that was this field is called a padding or the data record field. So next, now till now I have covered all the um, fields which are comes under the UDS message, that the CAN identifier, then the PCI, then we talked about the service IDs, that service identifiers, okay, the subfunction, right, the padding, that is the optional field we are talking about. So let's look very closely about this message structure. So generic service request message format, how the message looks like in the UDS protocol. It starts with the CAN identifier. Now, just remember, this CAN identifier is not a standardized. Okay, for few services, yes, it is standardized, but again, it is based on the need of the specific service needs to be implemented by that OEM. They can implement the identifier, but it must be mutually agreed between the tier one supplier, tier two supplier, as well as the OEM and the supplier and uh, the tool developer. Okay, the next field comes as a PCI, right? And this PCI field is a 1 to 3 byte in the length. And the next field is a service identifier field, and it is 1 byte identifier field. Then the subfunction byte, as I said, it's optional field. And in many services, it is not required, but in the few services, yes, it is required. And then the next one is a did, where you request the data parameters. The length is 2 byte. And the last field is a padding field, and it's an optional field. So this is how the frame looks like. If you go and see online in my live example, I'll show you. You can see the identifier, then the PCA information in the frame, then service identifier followed by the subfunction. But if it is applicable, then the request data parameter and then the padding field. That is the optional field. Again, if it is required in that service, it would be there. Otherwise, it won't be there. So simply tester sends the request to the ECU, and according the ECU response. So now we have seen the request. Okay. So now let's see about the response. So there are two types of the response. Either you can get the positive response or you can get the negative response. So now we have gone through the main aspects of the UDS request. Let's look briefly about the response frame. When ECU responds positively to the UDS service, the response frame is structured with a similar element as the request frame. Okay. For example, positive response to a service 22, that's the read byte by identifier request, will contain the response that service identified 62. Why 62? Because positive response, that's why 40 is added. So corresponding to the 22 plus 40 and the 2 byte did, followed by the actual data payload for the requested did. So generally, the structure of the positive UDS response message depends on the service, right? Which service you are expecting. That's very important to understand. So this is how testers send the request and you get the response. Okay, so just an example, I taken the one identifier to make you aware. Let's say this is not standard, but just an example. So identify, then you are starting with the protocol information that the PCI field. Assume that you are getting the positive response. Then you got the positive response added 62. I mean, the 40 is added into the 22 service. That's what you got the 62 and the identifier that's did, that's F40D service you are expecting. So you got the data payload That's the 4. And then is a padding field if required. So this is how you get the positive response for the service request 22. Okay, this is requested, 22 is requested, and you got the positive response in response to that service is 60, that 40 is added. That's what 62, right? Now let's see the negative response. What happens in case of the negative response, right? So let's start with the identifier, then followed by the PCI, and here you get the seed. And as I explained earlier, for positive response, you get 40 added into the requested seed. But for negative response, there is a single code and it's standard across all the services, that is a 7F. So you get the negative response, that's the 7F. So as soon as you get the 7F, you understand that that service is not implemented or not supported by that specific issue or by a specific server, right? So this is a rejected set and a negative response. And it defines also in what sense this negative response. So it defines with the code also. That is very important. And from this, with the help of this code, you understand what is the reason, whether it is not supported, not implemented, or anything else. It clearly defines that. And let's look out more in detail about this NRC codes. So what are the different NRC codes? Falls under these negative responses. So these are the codes. So if you remember earlier, I explained um, that we were getting the negative response. So what was that negative response? The negative response that was 13. So 13 means the invalid message length or the invalid format. So it also explain you with the code. If you get the code of 33, that means security access is denied. If you get the code of 72, that means programming is failure. Accordingly, you get the code and you have to decode this code from this list and understand what that meaning is for. So however, in some cases, the issue may provide a negative response to the UDS request. For example, if the service is not supported. Now let's enter to the diagnostic session control. So this is basically the service. So I'm gonna make you, now till now I covered about the basics, why it is needed, what are the reason behind invention about the UDS. Then we talk about the client server topology. Then we'll also, I started with the introduction. What is the UDS? What are the different available services under the UDS? What is message structure? And what is in the message structure? I talked about the request message, and in the response message, we also covered the positive response, negative response, and in the negative response, we also covered about the negative response codes, the different negative response code. So as I told earlier, there are 27 standard diagnostic services. Out of that, I'm going to talk here on the 3 services in the detail. I'm not going to cover all the diagnostic services supported by UDS, but I will cover 3 diagnostic services in detail and we'll look the live example of the one diagnostic service session. So let's diagnostic service. So out of that, let's start with the diagnostic session control. This is very important. And why it is important? Because you will understand that what is the importance of this diagnostic session control service. But as I explained earlier, each service has a unique identifier and that ID is called SID, right? So this service has a service identifier and that is a tail. And this service is used to enable the different diagnostic session into the ECU. ECU having the different diagnostic sessions. It might be the default session, it might be the programming session, it might be the extended diagnostic session, anything. So this service is used to enter accordingly as per the need or to enable the different diagnostic session into the ECU. So this is used to enable the specific set of the diagnostic services and or the functionality into the server. Okay. So there shall always be exactly one diagnostic session active into the server. Okay, it is not possible to have uh, the 2 diagnostic session active at the same time. What are these diagnostic sessions? So we'll see into the shortly. So it shall always start with the default diagnostic session when you power the ECU. As soon as you power the ECU always enter into the diagnostic session in the default session. Okay. What are the different diagnostic sessions available into the ECU? First one is a default session. Okay. So the default session is a diagnostic session enable all diagnostic services required to support the memory programming of the server. It is a vehicle manufacturer specific whether the positive response is sent prior or after the issue has switched to and from the programming session. In the case of server runs the programming session, in the boot software, the programming session shall only be left via an ECU reset service initiated by the client. So the another service is a programming session. And this is also very important. If you are in the boot software, if you are in the application software or the flashing application software, you need to use this session, or you need to use this as a function of this diagnostic session. Okay. And the next diagnostic session is extended diagnostic session. This uh, diagnostic session can be used to enable all diagnostic services required to support the adjustment of the function like idle speed or any value, or as I said, like emission values or something, CO values or something. So in the server's memory, it can also be used to enable the diagnostic services which are not specifically tied to the adjustment of the function. Okay. And the next is the safety system diagnostic session. This diagnostic session enable all the diagnostic services required to support the safety system related to the function like airbag deployment and all. So that falls under this safety system diagnostic session. And the last is a vehicle manufacturer, not a last, second last, vehicle manufacturer specific session. And if you see, the subfunction ID is also written. When I say 1001, that means you are in the diagnostic session in the default session. Um, if I say 1002, that means you are in the programming session. When 03, that means extended diagnostic session. 04 means it is a function ID basically. Safety system diagnostic session. And then the vehicle manufacturer specific session having the uh, subfunction IDs ranging from 40 to 5. And the last is a system supplier specific session that range from 60 to 7E. Now, to understand this diagram, very simple. When you work on the diagnostic session, um, as soon as you power on your ECU, the ECU enters into the default station. But in the default station, you don't have access for all the services, right? As I mentioned, writing writing or erasing the memory, or write any identifier, or accessing the keys or writing the keys. That's not possible in the default session. So when the server is in the default session and the client requests to start the default session, then the server shall reinitiate the default session completely. Okay. So, and the server shall reset all the activated, initiated changes, settings, controls during the activated session. This does not include long-term changes programmed into the non-volatile memory or the other transition to any default session. When the server transition from the default session to any other session, which I just covered earlier, that's the programming session or extended session, right? So to any other from the default, then the default session, then the server shall only pause the event similar to the stop response on the event in the time period since the non-default session is active that have been configured in the server via the response on event. Okay. When the server transition from any diagnostic session other than the default session to another session other than the default session, including the current active diagnostic session, right? So it should initialize the diagnostic session, which means that each event that has been configured in the server via the response on event, right? Security shall be relocked. All the other active diagnostic functionality that is supported in the new session and is not dependent upon security access shall be mentioned. Okay, these are the important points you need to care about this. So when we are jumping, so whenever you are going from default session, uh, any other session, then so you can go from any of the session, and if you want to go back to that session, then again you need to come back to the default session and again go back to the specific service. Sometimes it is allowed to jump from specific service to the or the specific session to the other session. This is the transition, how the diagnostic session transition happens. So in very simple language, I have covered what are the diagnostic session control service. Now we are jumping to the security access service. And as I explained earlier, again, this service also having the identifier, and that identifier is a 27 service identifier. So when I say the 27 seat, that means you are working on the security access service. The purpose of this service is to provide a means to access data and or the diagnostic services which have restricted access for the security, like emission or the safety reason. Diagnostic services for the downloading and uploading the routine or data into the server and reading specific memory locations from the server or situations where security access may be required. So the security concept uses a seed and key relationship. That is important. When you are talking about the security writing or accessing specific security related services, you need to use the seed or the key relationship. How it works? Initially, client requests the seed and then the server sends the seed back. Then the client sends the key appropriate for the seed received. Then the server responds back to that key was valid and that it will unlock itself. This is how it works in the seed and key relationship. So this is the security access service. Now I'm gonna jump to the third service, that is a write data by identifier. And for this service, 2E is the service identifier, service ID. Whenever you get the 2E, that means the tester want to write some data into the ECU. So the write data by identifier service allow the tester to write information into the ECU at an internal location specified by the provided data identifier. Data identifier should clearly mention at which location you want which information to write. That information should be provided by the tester. The write data identifier service is used by the client to write a data record to a server. The data is identified by the data identifier and may or may not be secured. So possible uses for these services are the programming configuration information into the server, that is the win number, then the clearing non-volatile memory, resetting a value, one of the value which are already learned by the issue. But if you want to reset that, then this service is used and setting up the option content. So this is how the right data byte identifier service is used. And sometimes the best example for right data byte identifier is if you want to change the maximum speed of the vehicle, you can use this right data byte identifier. Sometimes the vehicle get locked for the maximum speed of 120 kmph or 180 kmph. If you want to open that, you can use this, change the parameter uh, with the help of the memory addressing and all, sorry. And then accordingly, you change that option, right? So this is how this right data byte identifier service is used. Now we are jumping for a live example. Here I'll show you for the diagnostic sessions. We'll go to the default session. As the tester requests to enter the default session, how you get the response as an extended session. Sorry, how you get the positive response from the issue, and then we'll see also for the extended session as well. So now we are gonna see a live example. In my case, I already connected the tester and send the request, and I capture the canalizer log, as well as I was aware of the identifiers which are required to access the specific service. Today I'm going to talk you only on, in this live example, I'll take you to the uh, diagnostic session service. And the ID for the diagnostic session service is 10. And then we'll see the subfunction, that's the subfunction service or the session is a default session. And also we'll see the extended session. So here what we have to see, as soon as you request, how you get the positive response, that we will see here. So as I have taken this log, I know the timestamps where I can find this extended as well as the default session. So let me go to that timestamp and then I will explain you better. Okay, so again, I need to little bit go ahead. Okay, again, I need to go ahead. But meanwhile, you see 3E is a tester present. So our tester is present into the network CAN network. And now I'll go very precise timestamp. You see here. Now the request is active, right? Who is sending the request? Let's see. So F9 is sending request. So this is a tester. This is a PCI field. This is a service ID, that is a 10. 10 means diagnostic session control. One is a subfunction byte. That subfunction byte means default session. So tester want to enter into the default session. Let's see what is the response from the ECU. You got the positive response. 06 is a PCI response, PCI field response. 50 is a um, service identifier response. 40 is added. That means you got the positive response. And there is no change in this is showing you are in the default session, right? So you are entered in the default session. If the service is not implemented, that means you will get the 7F, that is a negative response. Now let's see for the extended session. So I will enter into the extended session and we'll see either you are getting the positive response or negative response. So now why the extended session is required? The extended session is required basically to access the few of the services like entering into the writing identifier or erasing the memory or writing some specific did service into the memory or writing the seed or accessing the keys or security related services. In that case, you need to enter into the extended session, right? So let me go to the specific timestamp. Okay. Now you see here is a request, right? This is not live. This is not active. If I see it is a blurred, right? So F9 is requesting to enter into the extended session. 03 is a subfunction byte. 03 means you wanted to enter into the extended session. This is a PCI field. This is a service identifier and subfunction ID, that is 03. Now, if I little very at very low timestamp, if I see I got the positive response, right? So, and that positive response is from the ECU because here F9 was a tester sending to the ECU F0. I got the response from the F0 sending to the tester, and that is 50. That means in SID 40 is added and 03, that is subfunction byte is not changed. That means the ECU is telling that you are in the extended session with the positive response. This is a PCI field and the subfunction ID is a 03. So that way you got the positive response. And I guess this is what I have to show you in the live demos for under the diagnostic session. If you are dealing with the tester, you don't need to use the canalizer tool even because most of the services are predefined under the tester, which is agreed between the software developer and the stack UDS stack developer. They agree and accordingly that service get implemented. Another important point is to remember that sometimes the OEM provide the tester tool to the dealers as well and offers them the basic training how to use that diagnostic tool and access the few of the services. We don't provide, or OEM doesn't provide full access like for the security services, but for the basic like what are the DTCs, active DTCs, how to clear that DTCs for the basic services. They develop the tool and provide to the dealer, and dealer I mean, the OEM trains the dealer's technician, so the technician helps to the customer to identify what is the root cause, what are the faults into the vehicle. So this is how the UDS service works basically, which helps you for identifying the bugs in the vehicle and defining what bugs is, or to access the different services, application code flashing, boot software flashing, um, so or writing some data or accessing the security access. So many services. I explained the 27 to 30 services are the standard services. Beyond that, the OEM implements their own services. So this is all about the UDS I have in today's session for you guys. So I really would like to know always what was valuable for you guys inside this video. What was your most valuable takeaway from this video? So tell me in the comment section below for a chance to be my next viewer of the week. I'll see you in the next one. Thank you for your time and please like, share and subscribe to my channel. Bye bye.